This is volumes of cylinders. Cylinders share many important characteristics with prisms. The first of which is, just like prisms, cylinders have two bases. In cylinders, both of the bases are circular. The lateral face in the middle of a cylinder, though, is a rectangle. And if you remember, all prisms' lateral faces are always rectangles. If you don't believe me, you can take a piece of paper and you can kind of curve that piece of paper until the two ends meet, and you can see how it would form the middle of a cylinder. And it is a rectangular piece when you unfold it. In order to find the volume of a cylinder, it's going to be the product of the area of the base, so how many cubic units fit in the base area, times the height, because that tells us how many layers high we can go to fill the cylinder. So area of the base times the height, the same volume formula that we use to find the volume of a prism. Let's take a look at some examples. In this first example, we're being asked to find the volume of the cylinder and round our answer to the nearest tenth. So the first thing I need to do is find the area of the base. Since the base is circular, I'm going to use my formula for area of a circle to find the area of the base. The formula for finding area of a circle is radius squared times pi. So I'm going to do 3 squared times pi. That's going to be multiplied by the height of my cylinder, which is 6. So I have to do my squared first according to order of operations, and I get 9 times pi times 6 equals my volume. If I round this to the nearest tenth, my volume is approximately 169.6 centimeters cubed. Let's take a look at this example. This time we're trying to find the height of the cylinder and round our answer to the nearest whole number. So I can find the area of the base. I have a diameter of 10 inches, so my radius is 5. So I'm going to do 5 squared times pi to find the area of my base, times the height, and the volume is given to me, 314 cubic inches. So 5 squared gives me 25. 25 times pi is approximately 78.5. And in order to solve for h here, on both sides I'll divide by 78.5. And 314 divided by 78.5, rounded to the nearest whole number, gives us a height of approximately 4 inches. In this example, we're trying to find out how much salsa is missing from this salsa jar. I can see the salsa jar is a cylindric type jar, and currently there is 4 inches of salsa left in the jar. Since the jar is 4 centimeters of salsa left in the jar. Since the entire jar is 10 centimeters tall, that means the empty portion, the missing portion of salsa, is 6 centimeters. So I can find the area of the base, multiply by that 6 centimeters to get my volume. So the base has a radius of 5, so I'm going to do 5 squared times pi. I'll do my exponent first, and I get 25 times pi times 6. And my volume, rounded to the nearest tenth, is approximately 471.6 centimeters cubed. So the empty part of this jar, the part of salsa that has been consumed, is 471.2, my mistake, centimeters cubed. Here we have a water cooler bottle that fits on top of your water cooler and contains many gallons of water. We want to know exactly how many gallons. So the first thing we're going to do is find the volume of this bottle here. So it's got a cylindrical type shape, and the whole bottom has a diameter of 1 foot. So when I'm finding the area of the base, my diameter is going to be approximated at about half a foot. So 0.5 squared times pi for my base, and a height of 1.7 feet. So 0.5 squared gives me 0.25 times pi times 1.7. This gives me my volume, but my volume is going to come out in feet cubed. In order to make sure that my answer comes out in gallons, I have to remember that for every 1 foot cubed, I get 7.5 gallons. So I'm going to modify my formula here to take whatever answer I get in feet cubed and multiply it by 7.5 so that my answer comes out in gallons. So the volume here is approximately 10 gallons in the container.